Assalamualaikum. My name is Tuba Gapar, roll number 233518, and my project name is Edit Distance. My other group member is Fatma Khalid. So, what is Edit Distance algorithm? It calculates the minimum number of operations required to convert one string into another. If we have two strings, we can perform following operations onto it to convert it into another string. We can insert any character into string 1, we can delete any character from string 1, and we can replace any character. Here are the some applications of edit distance problem: spell checkers, DNA, plagiarism detection, NLP, and search engines. Why are we are choosing dynamic programming? If we use brute force or name-based approach, it recalculates the same problem repeatedly, resulting in severe inefficiency. Time complexity of using brute force approach is big of 3 raised to power m, which is very large. We use dynamic programming because it overlaps subproblems, optimal substructure, and structured efficiency. Dynamic programming divide the problem into smaller subproblems and reuse the smaller subproblems multiple times. So algorithm make a 2D dynamic programming table with whose structure definitions are as follows. We represent row by I, column by j. Each cell value has an index of both row and column. The final solution is stored in the bottom right cell of the table. So here are some base cases of algorithm. If string 1 is empty, then we have to insert all the characters of string s2 to convert it into string s1. If string s2 is empty, then we must delete all the characters of string s1. So here is a recurrency relation. If the characters match of string s1 and s2, then we don't have to apply any operation onto it. And if characters doesn't match, it takes the minimum of 3 operations, which is insert, delete, and replace, then add 1 to it. And here is the flowchart. The algorithm starts. It creates a table of size m plus 1 cross n plus 1. It fills all the rows and columns by 0. It initializes the whole table with 0. Then it iterates through each cell, compares all the characters. If characters match, then it doesn't perform any operation. And if characters doesn't match, it takes a minimum of insert, delete, and replace, and then add 1 to it. And it stores the output to the top bottom right corner of the table. The visualization. User enters two inputs. User input 2 strings. Let's say Tuba, string 1 is Tuba and the other string is Gafar. Then it creates a table of size m plus 1 and n plus 1. M is the size of the row and n is the size of the column. Then it visualizes row by row and stores the final solution in the bottom right corner. Here is the DP table that is initialized by the 0. The user has input 2 strings. The first string is setting and the other string is kitten. First of all, it created a DP table and initializes all by 0. And here edit distance is 0. And here is the final result where it has calculated the edit distance, which is calculated 4. So in this case, minimum edit distance is 4. So time complexity. Time complexity of edit distance algorithm is big of m cross n if we use dynamic programming approach. So m is the length of string s1 and n is the length of string s2. It has time complexity of m cross n because the algorithm builds 2D table of size m plus 1 cross n plus 1. It has a space complexity same as the time complexity, which is big of m cross n, as it is maintaining and storing a table of size m plus 1 cross n plus 1. So here is the comparison of approaches: recursive memoization and dynamic programming. So recursive approach is very slow and very impractical for long strings, and has a very high time and as well as space complexity. As well as memoization has a time and space complexity same as the dynamic programming, but still has recursive function calls overhead. But the dynamic programming use iterative approach, easy to visualize via table. So here is the code of algorithm at a distance. I have used JavaScript language. So here we can see the first function is start. Start function takes two input from the string from the user. Strings are stored as first string is stored as str1 and the other string is stored as str2. Then it initializes each column and row by 0. Here are two lines. Then the next function is next row. The next row function fills one row of the DP table at a time. Here is the logic of added distance algorithm. If the string two characters match, then no operation is needed to apply. But if both characters doesn't match, it takes the minimum of insert, delete, and remove operation, then add one to it. If characters match, then if statement is executed. If characters doesn't match, then else statement is executed. Then the explain exact function backtracks and calculate the operations that are required to convert the one string into another. Render function explains which operations are performed on the string. So here the draw table. It draws a table of the size m cross n. M is the size of row and n is the size of column. So here is my code explanation. So here is the visualization of algorithm at a distance. So if we enter two strings, let's say my name, Tuba Ghaffar, and click start button, then here we can see a DP table is created and initialized by 0. When we click the next button, it calculates the minimum operations row wise. Now, here we can see it takes 6 operations to convert a string Ghaffar into a string Tuba. So, so here our final solution is 6. And here is the explanation of how one string is converted into other. Our first string is Tuba and the string 2 is Ghaffar. So we have to perform 6 different operations. Here 4 are the replace operations and the 2 are insert operations. We have to replace T with G, O with H, O with A, B with F, and have to insert F and R to convert string tuba into a far. So if we see another example, let's see both strings are same. Then here we can see again DP table is created, and here minimum distance is 0. Because both strings are same, we don't have to perform any operation to convert one into another. Minimum edit number of edits are 0. So here is the analysis of best, average, and worst case. So here we can see time complexity of all the three cases is same, which is big of m cross n. Because if even if all the characters match, full DP table is computed.